Hi there. Today we are looking at question 16, 2012 HSC Mathematics Part C. The circle x squared plus y minus c squared in the bracket equal to r squared, where c is greater than 0 and r is greater than 0, lies inside the parabola y equal to x squared. The circle touches the parabola at exactly 2 points located symmetrically on opposite sides of the y-axis as shown in the diagram. So we have this Cartesian plane and we have this parabola, and inside that parabola we have this circle with the center 0 and c, and as you can see it touches the parabola at 2 points. Part I show that 4c is equal to 1 plus 4r squared. To answer this question, we use the fact that when two curves are tangent to each other, when you solve them simultaneously, you should get one answer. So that means that if you have a quadratic equation, its discriminant must be equal to 0. So we solve them simultaneously to find the intersection. So y equal to x squared and x squared plus y minus c squared is equal to r squared. So we can substitute for y, or for x squared rather, from the first equation in the second equation. So in place of x squared, I'm going to sub in y in this equation. Then that's going to be y, which is replacing x squared, plus y minus c squared is equal to r squared. Expanding that, we'll get y plus y squared minus 2cy plus c squared is equal to r squared. And taking everything to one side, you get y plus y squared minus 2cy plus c squared minus r squared equal to 0. And arranging in the order of powers of y, you get y squared plus y minus 2cy plus c squared minus r squared equal to 0. And factorizing for y, you get 1 minus 2c plus c squared minus r squared equal to 0. Now we have a quadratic equation for y. So we want this quadratic equation to have one solution. Alright, so we need one solution only. So they are tangent, okay? So the two curves are tangent. Okay, so delta then must be equal to 0, and delta or discriminant is b squared minus 4ac. That is my b, that bracket. So then 1 minus 2c squared, that's the b, minus 4, my a is just 1, and my c is c squared minus r squared, and we want this to be 0. Expand this, you get 1 minus 4c plus 4c squared, and expand the second one, minus 4c squared plus 4r squared equal to 0. And these two cancels out, you end up with 1 minus 4c plus 4r squared equal to 0, and if you rearrange it, you get 1 plus 4r squared, and take this to the right hand side and change the sign, you get that, which is what they asked us to prove. That is for part I. part I deduce that C is greater than half. For this, we notice that when the circle is here, right, touching the origin, so practically you have 1 point of contact when your circle is right going through the origin. And in this instance, that is the optimum situation that you can have. And in this case, that is the value of C, which is equal to R. So in this situation, so in the optimum situation, the parabola and the circle touch at the origin. In this case, C, which is the center of that, is the same as radius, because that's the radius. C is equal to R. So from the previous part, we had 4C is equal to 1 plus 4R squared. And in place of R, I'm going to put C. So 4C is equal to 1 plus 4C squared. So this gives us a quadratic equation in this form. So if I take it to the other side and change the sign and rearrange it, so that's the quadratic equation for C. Then if I solve that, C becomes minus B, using the quadratic formula, plus minus the square root of minus 4 squared minus 4A, which is 4 times C, which is 1, divided by 2A, which is 2 times 1. So that becomes C is equal to 4 plus minus, that turns into 0 over 2. And sorry, here my 2A, A was 4. I should have put 4 here. Okay, that turns into 8. And that gives us C is equal to 4 on 8, or C is equal to half. That is the minimum value that C can have at that position. So to have 2 points of contact, we need C to be greater than that and go to a position similar shown in the first diagram. So to have 2 points, so this had only 1 point of contact. C must be greater than half. Thank you and see you next time.